So let us now continue our discussion. So let me just pinpoint the difference between frequency distribution and then the weighted mean. So weighted mean is meant for a sample, wherein in that sample, they have different weights or importance. And then in frequency distribution, mostly we use this one with a population or with a data wherein we have 50 or more. Okay. So if we have let's say ranking of importance of data, so we use the weighted mean. So if you're going to take a look on this one, where is that one? So here, x times w. So actually the entire formula is the same with the frequency distribution. It's just that you have to change this w into f. Okay, so you can solve any of those two with the use of this kind of formula. It's just that you have to use this one, this w for when it comes to importance of the data, and then f is for the frequent, okay, prompt or occurs of that data. Okay, just like 50 or more. All right. And then the next one with frequency distribution is where is that one? The measures of dispersion. So if you're not satisfied with the answer that you get from the central of tendency or central of, is it central tendency? Let's go back. Yeah, central tendency. So we have another one, which is the measure of dispersion. Okay. So under measure of dispersion, we have the range. Okay. So in the preceding section or topics, we have discussed the type of average like the mean, the median, and then the mode. So some characteristics of a set of data may not be evident from an examination of averages. So for instance, let's say we have this kind of example. So if you're going to use the mean, median, and mode, so that is not enough. Okay, so you will know why later on why those kind of averaging is not enough. So in here we're going to use the range. Okay, so to make or to give you a short meaning or definition of range. So range is actually the difference between the highest data uh, versus the lowest data. So let's say 1 to 10. So the range of this one is 10 minus 1. So they have a range of 9. Let's say 9 meters. Okay, if you're going to consider that one as a distance. So in here, we use range because we want to get the, uh, say, the margin of error of a certain machine. Okay, like for example, it doesn't have to be that exact, but it doesn't have to be that quite far when it comes to measuring the exact or this one the expected result. Okay, so for instance, consider a soft drink dispensing machine that should be dispensing 8 ounces of your selection into a cup. So the table below shows data for 2 of these machines. So we have one machine wherein it dispense 8 ounces, and then the other one also dispense 8 ounces. But if you're going to take a look at this one, on the machine one, we have on the cup one. Cup one, it dispenses 9.52 ounces. The second cup, it dispenses 6.41 ounces. The other one is 10.07, 5.85, and then 8.15. And then, of course, if you're going to get the average of this one, you will get 8.0. How come? Because it's already in the machine. And then as we all know, the machine should divide it by 5, like equally, 8 ounces, 8 ounces, 8 ounces, 8 ounces, 8 ounces. But we have a faulty machine in here, okay? So as you can see, on the first cup, it dispensed 9.52. So it's more than 8 ounces, which is 9.52 divided by 9.52 minus 8 is 1.52. Okay, so it's more than 1.52 ounces. So yes, it's good because the customer is happier because he got more than what he has paid. But on the second customer, he only got 6.41 ounces, wherein he should be expecting 8 ounces on every cup. So if you're going to take out on this one, uh, some people or some customers might report this one as, not functioning very well. Well, if it's more than 8 ohms, then they will say that, yeah, it's working perfectly because it's more than the expected uh, result or given ohms. And as you can see, it's super unbalanced or not that good when it comes to dispensing its expected uh, ounce of Coke. So some are 10.07, 5.85, and then 8.15. And then the other one is the machine two, wherein we have 8.01. So yeah, it's like perfect since we cannot notice that's a zero 0.01 anymore. And then even 7.99, it's already good since we cannot really notice if this one is exactly 8 ohms or uh, more than the 8 ohms. Then we have 7.95, which is not that bad also. And then 8.03, which is more than the 8 ohms, but only a little. And then 8.02 ohms, which is also more than a little. And then again, if you're going to get the average of this one using the mean, of course, you will also get 8.0 because those machines are told to divide it by 5, wherein you get, or let's say, or it will dispense 8 ohms exactly. Okay, so in here we're going to use the range, okay, because this arithmetic mean is not enough. It will not show anything, okay, that we need. Okay, so you want to get the margin of error, so it will not show you any data since you will get the same result. So 8.0 here and then 8.0 here also. Okay, so the mean data value for each machine is 8 ohms. However, look at the variation in data values for machine 1. So the quantity of soda dispensed is very inconsistent. In some cases, the soda overflows the cup, and in other cases, too little soda is dispensed. And then the machine is obviously needs adjustment. So machine 2, on the other hand, is working just fine. The quantity dispensed is very consistent with little variation. Okay, so here's the main definition of the range, which we're going to use later on. So the range of a set of data values is the difference between the greatest and then the least data value, as I have said a while ago. Okay, so from here, if we're going to go back here, the highest one is 10.07 and then the smallest one is 5.85. So 10.07 minus 5.85 is equal to, I'm not sure, maybe 4 point something. So as you can see, it has a more than error. How do you say that one? Or it has super, okay, super far, or it's not close to the expected result anymore, which is kind of bad. So in range, the smaller the range, the better. Okay, the higher the range means the more faulty the machine is, or the more faulty the whatever is at what. Okay. All right, so let's have an example for real. So going back to the machine 1 and then machine 2. So we have same data, and then the greatest number of ounces displayed is 10.07 and the least is 5.85. So the range of numbers of ounces dispensed is 10.07 minus 5.85 is equal to 4.22 ounces. So it's like, here's the margin of error or the error of the machine itself. Okay. So if we have a margin of error between, let's say, maybe or less than 1, okay. So if it's 8.5 or 7.55 when it comes to ohms or 8 ohms, so I think it's still good, still will pass the quality assurance of that machine. But since we already have more than one, which is, let's say, yeah, 4.22, so it's 4 times the expected margin of error. So this is already too much, meaning you need to adjust that machine already, right? So this is the answer, or this is the solution for the machine number 1. So in your quiz, you're going to get the range of the machine number 2. So find the range of the numbers of ounces dispensed by machine 2 in the table below. So this is already like a bonus, but I just want you guys to uh, uh, experience how to get a range. So later on, you'll get, or you'll be having more of this one once you have your final exam. Okay. So before we proceed to the next one, do you guys have a question so far? Question?
Wala po.
So how about the others? So we
Sir,
have a
wala
lot of
rin.
right. Okay, about you, Mr. Erlin, and then Miss Vera, and then Mr.
Wala, sir,
Ian, and
wala.
then Emilio. Okay. Right. So to those who didn't answer, so if you guys have a question, so don't be shy to ask. So I don't bite. So feel free to ask anytime. Okay, so moving on, we have the standard deviation. Okay, so what is this standard deviation? So with the knowledge or with the use of the so-called the range, so the range of a set of data is easy to compute, yes, but it can be deceiving at the same time. Okay, so the range is a measure that depends only on two numbers, okay, which is the highest or the most extreme values, like the highest and then the smallest, and as such, it is very sensitive. Okay, so a measure of dispersion that is less sensitive to extreme values is the standard deviation. So we could say that for quick results, so we could use the range. But for more reliable result, so we're going to use the standard deviation. Okay, so the standard deviation of a set of numerical data makes use of the amount by which each individual data value deviates from the mean. So these deviations represents x minus the x bar. So are positive when the data values is x is greater than the mean, and then x bar are negative when x is less than the mean x bar. So the sum of all deviations, x minus x bar, is 0 for all sets of data. So this is shown on the right side table for the machine number 2. So take note, this one is the machine number 2 already, not the machine number 1. Okay? So same concept or same idea with the range. So the lesser the range or the lesser the deviation, the better. Okay. So our minimum standard when it comes to saying that this one will pass is it should be less than 1. Okay. If it's more than 2 already, or let's say more than 1, okay, let's say 1.5 or 2, then that is not a good margin of error already. Okay. So of course, we don't expect the machine to work 100% perfectly. So humans commit mistakes. So sometimes there are also some glitches or some bugs or some misconfigurations when it comes to machines. But of course, companies try to make it as perfect as possible. But we cannot avoid that one, of course. Just like this one. Okay, so again, this is the data or the 8 ohm, 7.99, and so on and so forth. And then the second step that you need to do is get the X bar. So what is this X bar again? So this is the arithmetic mean or just simply the mean. Okay, so just add all of those and then you will get 8. So as you can see right here, 8.01 minus 8. So it has a standard deviation of 0.01 or it's more than 0.01. Okay, from the standard, which is negative 8 or 8. So sorry, not negative 8, but positive 8, okay, which is 8 ohms. So it's more than 0.01, which is good. It has a very little deviation. And then the other one is negative 0.01, wherein it is also good. It lacks, okay, negative 0.01, which is unnoticeable. The other one is negative 0.05. Wherein, yeah, still good since it's still less than 1. Okay. As long as it's less than 1, okay, 0.99 and below, it is still good, right? So it's still considered as an okay product, okay? But of course, the lesser the deviation, the better. The other one is 0.03 and then 0.02. Then for you to be able to check, say whether this one is correct or no, so the sum of deviations must be always equal to 0. So this is just for you to check if you get the correct deviation. So in those 5 cups, we have a deviation of 0. So 0.01 here, 0.01 here, and then some of them lacks, some of them is more than, and then some of them is also more than. So if you're going to add all of those, you must have, or you must get 0, right? So did you guys get the idea of standard deviation so far? So the only difference between the standard deviation and then the range is the every computation of the number. So in range, we only consider the smallest and then the largest. But in standard deviation, we do that one in every data, okay, just like this, right? So same concept or same idea, the lesser the deviation or the lesser the range, the better. Okay, so any questions so far?
Wala po.
Okay, so uh, you might maybe wondering, where do we use the standard deviation? So this again is used by the companies. Okay, so they use this one to check whether there is a margin of error in their products. Since of course, like anong pinamagandang example? Pansit Canton. Yeah, in some Pansit Canton, there are some packs wherein it has two sauce. Like the default one, it should be, or it should have a soy sauce, uh, what is that? What seasoning, and then some has an oil, but the other one or the others doesn't have an oil. But mostly that's the standard packaging. But some has an extra oil and an extra soy, or some even has an extra seasoning. So that's the error that is being made by the machines. Wherein, if you're going to calculate that one, maybe it's already more than one because, of course, the other pack won't be having uh, a seasoning anymore because it's in the other packaging. Okay? So that is where they usually use the standard deviation and then the range. Okay, and then we have two different kinds of deviations. One is for the population, for the entire count of data, and then samples is just for the portion of that populations. Okay, so for the population, so we have this kind of formula. Anyway, so if x1, x2, x3 up to the, let's see, up to the end is a population of numbers with a mean of mu, then the standard deviation of the population is, what do you call this one again? I forgot. I think it's, I forgot. So anyway, this symbol is the standard deviation. Okay. So if there's anyone who knows theta, no, no, gamma, beta, I'm not sure. Anyway, so this is the symbol for the standard deviation. So you can maybe, if you're curious what is the name of this one, so you might want to ask Mr. Google. So he's my friend, so he's very friendly. So just ask him anytime. Okay, he doesn't sleep as long as you have the internet. So this one is equal to the square root of summation of x minus mu. Okay, and then squared divided by n. And then for the sample, okay, so standard deviation of the sample is S. Okay, so here's the symbol for the sample. Okay, standard deviation of the sample, wherein square root of summation of x minus x bar, and then parentheses squared divided by n minus 1. So as you can see, the only difference is this one. Okay, So the mu and then the x bar, wherein mu is the mean of the population and then x bar is the mean of the sample. So basically this one and this one are just the same, just a different symbol. So this one is representing the mean of the population and then this one is representing the mean of the sample. And then the only difference is the denominator, wherein for population should be divided by n only, and then for the sample it is n or divided by n minus 1. Okay, so I would say that you don't have a problem when it comes to using those formulas since it's already open notes, so no worries when it comes to memorizing. Right? So let's have uh, the procedure for computing standard deviation. So we actually have 5 steps. So the first one is determining the mean of the n numbers. So if it's a population, so your symbol for the mean should be mu. But if it's a sample, then the symbol for your mean should be x bar. Okay, so basically same way of computing, just a different symbol. Number 2, for each number, calculate the deviation difference between the number and the mean of the numbers. So just like what we did before, okay, it's 1. So getting the standard deviation, so just get the mean of this one and then deduct it with your data. Okay, so 0.01, negative 0.01, so those are the results of step number 2. Okay. Number 3, calculate the square of each deviation and find the sum of these square deviations. And then, so later on, I will show to you guys on the next example since we don't have that one in the past examples. So if the data is a population, then divide the sum by n. And then if the data is a sample, then divide it by n minus 1. And then lastly, once you're done with those 4 steps, find the square root of the quotient in step number 4. So for you to appreciate or understand this one a little bit more, so let's have an actual example. So find the standard deviation of this example. So the following numbers were obtained by sampling a population. Okay, so our data came from the population, which is now just a portion, which is just a sample. Okay, so 2, 4, 7 to 15 is just a sample. So the arithmetic mean symbol that we're going to use is x bar. Okay, so for the population, it's mu. But since this one is a sample, so we're going to use the x bar. So the question is, find the standard deviation of the sample. Okay, so just apply those 5 steps. So step number 1, step number 2 is already here. So first is get the arithmetic mean, wherein we have, say, let's say 8. Okay, so never mind the verification whether this one is correct or not. Let's say we've just already get the uh, arithmetic mean, which is 8. Okay, so again, use the symbol x bar since we have a sample. Okay, and then step number 2, for each number, calculate the deviation between the number and then the mean. So just get, just deduct it with our data. So 2 minus 8, 4 minus 8, 7 minus 8, and so on and so forth. So once you're done with that, so just leave it as it is. So negative 6, negative 4, negative 1, 4, and 7. And step number 3, calculate the square of each deviation in step number 2 and find the sum of these squared deviations. So from here, this is our step number 2. Here's now our step number 3. So just basically squared it. Okay. So negative 6 times or negative 6 squared is 36. Negative 4 times 2 or negative 4 times 2. Negative 4 squared is 16. And the negative 1 squared is 1. 4 squared is 16. 7 squared is 49. And then negative 6 squared is 36. So as you can see, whether you have a positive or negative value, it will always become a positive value since they are squared. So just add all of those. Then here's now the sum of the squared deviation for the step number 3. Okay, so we have 118. Just remember that one. And then step number 4, because we have a sample of n is equal to 5 values, divide the sum 118 by n minus 1. All right. So again, since we are in sample, okay, so it says here, or just this formula itself. So if we are in sample, it should be divided by n minus 1. So how many numbers do we have? So n is, where's that one? So 5, I think. So which is 4. Yeah. 5 minus 1 is equal to 4. Okay. So 118 divided by 4 is 29.5. And then step 5 is the square root of this step number 4, or the result in step number 4. So the standard deviation of the sample is S is equal to the square root of 29.5. So if you're going to calculate this one, standard deviation is 5.43. All right. So yeah, that's it. So that's how you get the standard deviation of a certain data. So it could be from population or from a sample. Okay, so before we proceed to the next one, do you guys have a question so far?
Sir,
Yes?
um, can we do like a shortcut? Kumbaga sa calculator, diretso na.
So hindi ko naman na malalaman yun eh. Okay. So as you may know, I've never asked for a solution. Okay, so lahat naman yun is parang, uh, yun, pinakita ko lang lahat yung solution para alam nyo kung paano siya gawin step by step. But in
Pero
reality,
sir,
you don't,
I mean
you don't need,
makukuha pa rin po yung
yeah,
right
same,
answer
same pa rin
kapag
yung answer. Actually, mas exact pa yun. Okay, lalo na kapag may mga decimals. But the reason why I don't show that one is mas magandang alam nyo pa rin yung step by step. Pero kung na-master nyo na yung, let's say, step by step, let's say, gawin nyo man lang yun, okay? Kasi hindi advisable na uh, gawin nyo lahat sa calculator and then without doing the step by step. So, mas mahihirapan kayo. So, ang advantage ng ginagawa mo yung step by step is makikita mo kung saan ka nagkamali. Okay? Unlike kapag sa calculator, so let's say, hindi lang 5 data. So, meron kang 10 or 15 datas. Sobrang haba na lang sa calculator. So, in some cases, hindi rin kasha. Okay. So, pwedeng magkamali ka ng pindot or magkamali ka ng pagkaka-insert ng mga kwan. So, yun. Pagka-equals mo, din ilalagay mo. Pero, yun, hindi mo na ma-check kung saan ka nagkamali. Unlike kapag step by step. Pero, nasa sa inyo na yun. Okay. So, pwedeng biglaan or pwedeng step by step. Okay. So, you can put it one time or one shot in your calculator. So, no problem. Okay. Any other question or clarification? So, if you're lost, sakaling hindi mo hindi mo masundan to, then balikan mo lang. Okay, so just read back and then balikan mo kung saan yung part na hindi mo naintindihan. Okay, so yeah. So for now, kailangan nating tapusin to unless gusto nyo magkaroon ng part 4. Kasi meron na lang tayong 8 minutes remaining and then we still have 8 slides. Okay, so meron pa tayong isang topic. Any questions so far? Ano yun?
Sa susunod na po.
Sunod na. Naka-schedule na to eh. Sakto, konti na lang yan. Isang topic na sobrang dali. Actually, yung step number 16 na yung pinakalas na tuloy niya to. Alright. So, mamaya ipapakita ko din yung sinasabi ni Ms. De Vera wherein you can do it one time, one shot in your calculator. So, pero bago yun, okay, so right after this example, of course, we're going to have a quiz on this standard deviation. Okay, so student has the following quiz scores 5, 8, 16, blah, blah, blah. So find the standard deviation for this sample of quiz scores. Okay. So another example is use standard deviations. So in this example, we will use standard deviations to determine which company produces batteries that are most consistent with regard to their life expectancy. So a consumer group tested a sample of 8 size D batteries. So lahat to 8 size D batteries from each of 3 companies. So we have Ever So Bright, Dependable, and then Nippon. So the results of this test are shown in the following table. According to this test, which company produces batteries for which the values representing hours of constant use have the smallest deviation? So again, the smaller the standard deviation, the more consistent the product is. The higher the standard deviation, meaning it already has a large margin of error. Okay, so again, the lesser, the better. So we have 3 companies. ever so bright, dependable, and then the beacon. And then here are the hours of constant use for battery. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 batteries on each, or yeah, in every company. So 8, 8, 8. Of course, we have different uses or hours of usage. All right. So for us to know which one is the smallest or has the smallest standard deviation, so let me show to you the solution. So here's what Miss Devet is talking about. So you can do this one as long as you can manage it, or as long as you or your calculator can manage it rather. Okay. So okay lang naman, no problem. So we have here the standard deviation for the ever so bright, dependable, and then the beacon. So as you can see, so all right. So I'll ask which one. So which company is the most consistent, okay, or the best to uh, price to performance ratio.
Dependable.
So it is dependable. So again, the idea of getting the standard deviation is for you to know whether it will pass or it will fail. Okay. So the lesser the standard deviation, the better. So the most least standard deviation here is the dependable, which is 0.719 compared to the other, which is 0.877 and then 1.328. Okay, so this is an explanation that dependable is the most reliable battery. Okay. Then after this one, of course, you're going to have a quiz, which is super similar. Now, instead of battery, you're going to test a rope. Okay. So you can do this one as long as you're, focus in inputting the values, because it's very critical if misclick or input a certain value. Okay. So I'll be leaving this one to you guys. So just file or just do something like this. And then the last one is the variance. Okay. So it is as is statistic known as the variance is also used as a measure of dispersion. So as you can see, this is also part of the 5 steps, as I have said a while ago. This is actually the step 6. So the variance for a given set of data is the square of the standard deviation of the data. So as you can see, whatever is the result of that data, let's say the standard deviation of that data, so just squared it actually. I Yeah, squared it. Just squared it. So the following charts shows the mathematical notations that are used to denote standard deviations and variances. Okay, so here are the notations for the standard deviation and then the variance. So as you all know, this one is a symbol for the standard deviation of the population. And then this one is also the standard deviation for the sample. So for you to be able to get the variance, okay, just square that standard deviation. Okay, so that's it. So if we have population, so just squared it. We have the sample, just squared it also. So basically the same. Okay, just the symbol is the difference. Okay, so let's say we have this example. So find the variance, blah blah blah, of the slide 43. So let's go back to slide 43. So the standard deviation of this one is this one, 5.43. So just squared 5.43, and then actually it will lead you back to this value, which is 29.5. So one tip here is you don't actually need to show the solution for the variance if I'm not asking you guys. So from step 1 to step 5, you already have your variance in there, which is the step number 4. So the standard deviation is the step number 5, and then the variance is the step number 4. Okay, so here's the solution. So from the variance itself, we have 5 point something. So just square that one. So yeah, the square root and then the squared will cancel. 29.5. Okay, so as simple as it is. So the variance is the most easiest part when it comes to calculating the var- measure of dispersion. But of course, if you have an incorrect, okay, standard deviation, you will also an incorrect answer in the variance. So you're like kambal, okay, brothers and sisters, or ano man tawag dito? Basta, Magkadikit sila palagi. Pag maling isa, mali na rin isa. Alright? So, any clarification so far?
Wala po.
Alright. So, we now only have 1 minute. So, here's your quiz on the variance. Okay? So, get the variance on the slide 47. Okay, and then that's it for this module. So, yay, we were able to finish that one in 3 sessions only. So, that's it for the statistics. So, if you guys have a question, so feel free to message me anytime to my messenger. Okay, so goodbye and then good afternoon to all of you.
Good
Bye, sir.
evening.
Thank you.
Sir, bye po.
Bye.
Sir.